answer the question on the screen, guys. We're going to look for, well, we're going to be sketching the graph of 2 over x minus 1. And then you need to find me the x-intercept, please, guys. So let me know what the x-intercept of my graph is going to be. Go through all the motions that we're used to, guys. Remember, find me my asymptotes, my y asymptote. My y cannot be equal to something. Oh, it's not 0. That's a lie. And my x cannot be equal to something. And then I know that my graph is positive, so it will fall into certain quadrants. And you guys can let me know what those quadrants are in the chat. Okay, this is just a revision of what we did on Wednesday. For those of you who are joining us for the first time and aren't sure what's happening, we're going to do a very quick revision of what we did last time. Hi, hello, Samuel. Amazing to see you. And Noma Khlubi as well. Noma Khlubi using different device. I like it. Nice name. Hi, Courtney. All right, we're going to get started in a minute or so. So I hope everybody's doing okay. Okay. Let us know how your exams are going. Ayaz, hello, Ayaz. Where have you been? It's been a while. Been a while, like a whole hot minute. How's it going? Oh no, Tiana, what is happening? Why are we just seeing flames? Why is there just flames right now? Hi, Swanelo. Tarika, are we sure? Have a look at our calculations again, my sweetie. Have a look at your calculations one more time and let me know. I'm glad you're good. I'm glad you're good, Ayaz. Asikewele. The exams are making me skinny. Oh, I'm so sorry. You know what? That means during the holidays, we must make up for all that stress, you know, by taking a real chill pill. You know what I mean? Hello, Queen Jasmine. Oh, guys, come on, guys. I'm sorry to hear it. We're going to get back into it quickly. But at the end of the lesson, we can have a bit of a chat about how everyone is doing. Okay, hi, Amara. All right, let's get started over here. You guys can pop my asymptotes into my chat for me. What can y not equal to? We should already know, because x is part of my denominator, that x cannot be equal to 0. And we know that our y asymptote is going to be the shift in our graph. So our y asymptote, y cannot be equal to -1. All right, so if I had to draw my graph, or my graphs, I would have an asymptote at -1 over there. That is my y, okay, which means it will be like that. And at x is equal to 0, which means this entire line over here, right? Now, because my graph is positive, my quadrants are going to be quadrants 1 and 3. So my graph needs to be drawn here and down here, right? Now I need to find this point over here. And we know, guys, if I'm looking for the x-intercept, y needs to equal 0. So I'm going to make f of x, which is the same thing as y. I'm going to make that whole thing 0. So I'm going to have 0 is equal to 2 over x minus 1. I'm going to take my -1 over to the other side, and it's going to become positive. So I will have 1 is equal to 2 over x. And then I will cross multiply, and I would have x, or 1x is equal to 2. So my x-intercept over here will be 2 and 0. Yes, that's it, Tyrika, you finally got it. Amazing stuff. Well, in any case, that is a recap of what we did on Wednesday last week. Good evening to everybody who's joining us. If anybody's joining us for the first time, can I ask you to put your hand up or just pop in the chat? Hi, I'm new. Who is giving us our classroom rules today? Queen Jasmine, where are you? I mean, where is Queen Jasmine today to welcome the classroom? I mean, come on, we don't pay you for, okay, we don't pay her at all. But hello, Queen Jasmine.
A good evening.
Good evening. Are you ready to say hello to everybody today?
How would you say half of it and then I'll do the end?
Okay. I love to hear it. Awesome. Awesome. All right. Somebody's just CJ's just asking to take a screenshot. Please, CJ, 5, 4, 3, 2, 1. To be looking at exponential functions. But after we look at exponential functions, we're also going to be doing an introduction to trig equations or trig functions, not trig equations, trig functions. Trig equations are grade 11 and they're very difficult. So we're only going to get to them in grade 11. Okay, no worries, Tyra. Welcome. Welcome. All right, so we're going to be looking at the graph of f of x is equal to 2 to the power of x. Now, when we look at a graph like this, an exponential graph, we're going to be considering two things, guys. We're going to be considering the asymptote. And we're going to be looking for the y-intercept. Now, this is for a positive graph. When we start looking at our negative graphs, we will also get x asymptotes. But in this particular graph, we're not going to get an x asymptote. Okay, we're only going to get a y asymptote here. Now, remember, guys, y-intercept, x must equal to 0. All right, now my asymptote over here, my asymptote for this graph is going to be where y is equal to 0. Okay, where y is equal to 0 or not equal to 0. That is the asymptote for the graph. Remember, guys, our y asymptote is always the number over here. But because in this particular graph, we don't have a number, we can just say plus 0. We can say plus 0. So our asymptote over here is 0. Asikewele, I will do so in just a little bit. All right. So what that means is my graph cannot touch the x-axis. It's my horizontal asymptote. So my graph cannot touch this part here. Okay, it cannot touch this part. Now, the next thing we're going to do, guys, is we're going to look for the y-intercept. If I make x 0, if x is equal to 0, what will y be equal to? I'm going to get 2 to the power of 0. And we know that 2 to the power of 0 is equal to what? That's it. 2 to the power of 0 is equal to 1. All right, so our graph, our exponential graph is going to go through the point 1. Right, so an exponential graph is always drawn in the direction that we see it. Because this graph over here is positive, our graph will go up. It will increase because our function itself is increasing. So our graph will move like this. That way, past the point, but it will not touch the x-axis because at y is equal to 0, we have an asymptote. Now, I see Askewele saying, ma'am, could you explain the asymptote part again? Okay, the reason why y is equal to 0 is an asymptote is when we make, and when we're looking for the y-intercept, we make x equal to 0. But if I had to look for the x-intercept, I would then have to make y equal to 0. So let's think about this, guys. I would have to write 2 to the power of x is equal to 0. Can anybody think of a number? Can anybody think of a number for x? Think of a value for x that will make my y value 0. 2 to the power of what is equal to 0? Let me know. Zoluga, because when we look for the y-intercept, x must equal to 0. That's why. We've made x 0. Tiana, if I put 2 to the power of 0, I'm going to get 1 and not 0. Okay? Anybody? Anything else? Amber says nothing, and I agree. I agree with Amber. There will be no number that I can put as a value of x that's going to give me 0. Okay, every number that I put in there is going to give me anything but 0. So what this means is that my at y is equal to 0, I don't have a graph. I don't have a graph. Christina says, ma'am, at school we normally use the mode table method on our calculator. Is that fine, or do we have to use your method? You can use your calculator. 100%, you guys, if you've been taught the mode exponential on your calculator, do that. The reason why I avoided Christina is because I now have to draw, a table. And mem and tables, we're not friends. I don't like tables. They take forever. So, not bothered about it. But if you've been taught how to use the graph, the mode function on your calculator to draw this graph, go for it. Okay, you're more than welcome to. But in this case, okay. Abiani, how are we doing, my sweetie?
I'm fine, thanks. And how are you, ma'am?
Excellent, my sweetie. What's up?
Ma'am, you said the y asymptote is y is not equals to 0. Is it correct? Are you not supposed to say y equals to 0?
Yes, y equal to 0. I'm just showing it's supposed to say y equal to 0. But if I say y equals to 0, I can already feel somebody putting up their hand and saying, but ma'am, you said y is equal to 0. And that's the only reason I put that thing. You're correct. It's y is equal to 0. Okay. But it gets confusing for some people. Okay. Because if I just write y is equal to 0, then they think that there's a graph at 0. You get why I'm but you're correct. Y is equal to 0, my sweetie. You're 100% on point. All right.
Thank you.
You're very welcome. All right, excellent. Okay, I will show you how to do that. User, please give us your name so that we can change your name for you and we can speak to you. Alusha, hello. I was wondering where you were because you're supposed to give us our classroom rules today. Hello, Alusha. No worries. All right, now we're going to look at the graph of, I'm going to change this one to -2 to the power of x, okay? -2 to the power of x. All right, that's okay, that's okay. No worries, Leabona. All right, guys, let's talk. Now I've got f of x is equal to -2 to the power of x. My y asymptote will be the same. It's almost like me adding 0 over here. So my y asymptote is where y is equal to 0 or where y cannot be equal to 0. Okay, so Abiani, I hope I'm not confusing you. Our asymptote is where y is equal to 0, which means our graph cannot cut the axis at 0. But if I look for the y-intercept, guys, then x needs to equal to 0. If I replace x with 0, what will my y value be? If x is equal to 0, y is equal to what? Pop your answer in the chat. Oh, yes, it's not going to be 1. It's not going to be 1, guys. Be very careful. That's it, Courtney. That's it. It's going to be -1. And for those of you who are like -1, how? Okay, here's how. There is a distinct difference between 2 to the power of 2 or -2 all to the power of 2 and -2 to the power of 2. This answer over here will be +4, and this one will be 2 to the power of 2, which is 4 with a negative in front. Okay, today's topic is exponential functions, and then we're also going to do trig graphs. We're going to start trig graphs, okay? Right, so in this case, when we say that x is equal to 0, we're going to look at 2 to the power of 0. Whatever the answer is that we get for 2 to the power of 0, we will put a negative there. Okay, we will put a negative there. Now we know that 2 to the power of 0 is 1, so my answer should be -1. All right, because the whole of -2 is not to the power of 0, only 2 is to the power of 0. All right, so now my y-intercept is now down here at -1. So because this graph is negative, now I'm writing positive. Because the graph is negative, guys, my exponential graph will curve downwards like that. It'll curve downwards. So we will draw our graph down here in this direction. Okay. Give me a thumbs up if the two graphs make sense. Excellent. Excellent. All right, cool, cool beans. Now let's move things up and down. Let's move things up and down. Yes, Tiana.
Ma'am, so I have a question.
Hmm.
So now, what does exponential, does exponential function, do we always like look for the y-intercept only?
No. In this one, because there's no asymptote other than y is equal to 0, no. But you'll see just now, I'm going to move my graph up. And then we're going to cut the x-axis in more than one place. And then it's going to start issues. Okay. I'm about to do that. All right. Asbonge, when you say, ma'am, I missed that, explain again, which part? That's it. Teacher knows you beat me to it. Okay. Yes. So Askewele, it's not always positive 2. It can be other numbers. It can be positive 3, positive 0.5, negative 1,5, okay, or negative 3/2. But we're going to talk about that just now. All right. Okay. Now, guys, let's look at the following graph. Okay. Let's look at the following graph. Oh, by the way, before we do that, oh, look at me forgetting the most important part. All right. So the original graph, guys, that you would get is y is equal to a times b to the power of x plus q. Now, when we see this graph like this, guys, this value, this b over here, is the same value as this 2 that I've put in my graph over there. I now say to you guys that this b cannot be equal to 1. Why can b not equal 1, guys? Who knows? Why can b not be equal to 1? Think about this, guys. If I wrote a graph of f of x is equal to 1 to the power of x, Tiana, what am I going to get?
Ma'am, if ma'am is to put a 1 there, all your answer is going to be 1.
Good, yes, that's it. So it's just going to give us a straight line, and that's not a graph. It's not an exponential graph. Excellent. That was the answer I was looking for. Well done, Tiana. Excellent stuff. Nice. If I put 1 to the power of x, 1 squared is 1. 1 to the power of 7 is 1. 1 to the power of -3 is 1. 1 to the power of 1/2 is 1. So I won't get a graph. I'll just get a straight line at 1. Same as if I said b cannot be equal to 0, because 0 to the power of anything is also equal to 0. So I would get a straight line at 0. So b cannot be equal to 0. B cannot be equal to 1, because at these 2 points, we're going to have issues. Same with this a over here. A cannot be equal to 0, because if a becomes 0, then I'm just going to get 0 across the board. I'm going to get 0 across the board, and my graph is going to be a straight line. So these things are very important. We need to make sure that we're considering them. Okay, I have a feeling some teachers might just ask this as a trick question. I've seen that before. So bear that in mind, guys. Okay. All right. So let's look at if my graph says, we're no longer going to be looking at f of x is equal to 2 to the power of x. We're going to look at if I said f of x is equal to 1/2 to the power of x. All right, I want us to consider this. F of x is equal to 1/2 to the power of x. Now, again, my asymptote will be at y is equal to 0. Now, if I make x equal to 1, or if I make x equal to 0, what will my y value be, guys? What will my y value be if I make x equal to 0? That's it. Good. My y value will still be equal to 1. But for this particular graph, I want us to consider something else. What happens if my x is equal to 1? If x is equal to 1, what is y equal to? Oh, not 2. A half to the power of x will give us, that's it, Asabuya, that's it, Nico, well done, Blaze. It will give us a half, right? If x is equal to 2, what will I get? Y will be equal to what? Good. 1 over 4. 1 over 4. So my graph is actually getting smaller on this side. But punch this into your calculator, guys. If x is equal to -1, what will y be equal to? Yo, Nico, I cannot really, like, no, you're moving too fast for me, my dude. Good. Y will equal to 2. When x is equal to -2, y is equal to? Good. Y is equal to 4. So what has actually happened is my graph has almost flipped. It's still positive, but it's positive on this side. So my graph will look like this. Like that. Okay. My graph will flip like that. Okay. Because I've put the half there. Half to the power of x. That's how my graph will flip. All right. What happens if I make it -1/2? If I make it a -1/2, what are we going to get? I know that at x is equal to 0, my answer will be -1. So my graph will start down here. My graph will be down here. But guys, consider x is equal to 1 and x is equal to 2. What are we going to get? At x is equal to 1 and x is equal to 2. X is equal to 2. Over here, y is going to equal to -1/2. At x is equal to 2, y will be equal to? Good. Negative. Negative up here. Don't forget the negative. -1/4. At x is equal to -1, what will I get? And at x is equal to -2, what will I get? Good. At x is equal to -1, y will equal -2. And at x is equal to -2, y will equal -4. Good. Right. So my graph will also be inverted in that it will move in this direction like that. All right. So what we take from this, guys, is if my value over here, if this value over here is between the values 0 and 1, my graph flips on the y-axis this way. Okay, it flips like that. You guys know what I mean, ish? It flips like that. Yeah, you guys understand, it flips that way. Right, but when my graph is negative, then it flips up, down. Up, down. Okay, give me a thumbs up if this makes sense. That's it. Good. In this graph, it flips over the y-axis. If my value is between 0 and 1, it flips across the y-axis. If it is negative, then it'll flip this way. Okay. It's a reflection, part 2, 100%. 100% it's a reflection. Okay. Excellent. They are reflections of each other. Beautiful, guys. Loving it. All right, now let's now shift things up and down. Okay. 2. No, not there. Down here. plus 2. Let's move things up and down, guys. Nico, if it's negative, then it flips this way. Okay. No worries, Askewele. No worries. We're just happy to have you back. Ah, there ma'am goes again. All right, let's talk about a couple of things, guys. If I have 2 to the power of x plus 2, my y asymptote then moves. My y asymptote moves. Oh, Lord. Okay, my new y asymptote is going to be this value here. So my y asymptote is going to be where y is equal to 2, right? So it's actually going to sit there. There we go. At 2. And then we can draw it across. Then we're also going to consider the y-intercept, where x is equal to 0. Now, guys, put that into the formula for me. When x is equal to 0, what is y equal to? Good. Ooh, not 1, it's going to be 3. Good. 2 to the power of 0 is 1, plus 2 is 3. So my new asymptote is going to be, not my asymptote, my intercept is going to be here at 3. So my graph will then look like that up here. Remember, it's a positive graph, so it must go in that direction. Okay. How do you know, ma'am, what y or x will be equal to? Askewele, we're looking at the y-intercept. We're looking at the y-intercept. And at the y-intercept, x is always 0. That's the thing that we're using in this graph. At the y-intercept, x must equal 0. And that's the thing we're leveraging. Okay, same with the x-intercept, y must be equal to 0. All right. Yes, Patu.
Ma'am, I wanted to ask, will the asymptote always be the value of q?
Yes, the y asymptote will always be the value of q.
Only the y asymptote?
Only the y. Yes. This
Okay.
number here. Because you know what, Patu, what it's actually doing is it's just taking the same graph that I've drawn and moving it up. So if my graph moves up, the asymptote will also move up.
Oh, okay, ma'am. Thank you.
Yeah. Excellent. All right. Okay, so when we draw this graph over here, we're going to get that line over there. Because my graph is positive, it will increase. Now, if I go to this graph over here, guys, negative 2 to the power of x plus 2. What is my y asymptote? My y asymptote is good at y is equal to 2. Now tell me about my y-intercept. Tell me about my y-intercept, guys, where x is equal to 0. What will y be equal to? Nico, you are on fire today. I mean, just killing it. Well done. Excellent. Y will equal 1. So my graph will cross there. Now, I want to show you guys something. If I draw my graph going in this direction, what do we notice? Has anybody picked up on it yet? What do we notice? What do we have here, guys? What do we call this thing? Who's got a name for it for me? Anyone? Oh, Namisile, yes, that's it. It's not a turning point, Samuel. It is the x-intercept. And what do we know happens at the x-intercept, guys? At the x-intercept, what? That's it, part 2. That's it, guys. Y is equal to 0. So we need to now go and calculate for our x-intercept. where y is equal to 0. So we're going to go 0 is equal to negative 2 to the power of x plus 2. That's okay, Samuel. We all have those days. Okay, we're going to take 2 over to the other side, and it's going to become negative 2 is equal to negative 2 to the power of x. What value of x do I need up here in order for this to be true, guys? What must this exponent of negative 2 over here be in order for this equation to be true? It's not 0, Anam. Good. That's it, Nico and Ogushe. The only way this holds true is if x is equal to 1. If x is equal to 1. Right. So we know that this over here needs to be 2 to the power of 1. Therefore, our x-intercept is at the point 1 and 0. Okay. Give me a thumbs up if everything we've just done now makes sense. Abiani?
Ma'am,
Yes.
I'm a bit lost when we draw the graph on where we know whether it's increasing or decreasing.
Whether we know if it's increasing or decreasing,
Yeah.
it will always be told by this value, that one.
Also, if that value is a negative, then our graph is decreasing. And if it's a positive, our graph is increasing.
Yes. Now remember, if this value over here is also between 0 and 1, then the graph must increase in the opposite direction. Okay, so if it's like a half, then it must increase going that way.
Okay.
All right.
Yeah.
The
Okay.
only difference.
Okay, thank you.
Right. You're very welcome, my sweetie. Okay, yes, Tiana.
Ma'am, why is x
Yeah.
1?
Y is x? 1. Okay, if I said to you, Tiana, that I've got 2 to the power of x is equal to 2 to the power of 2, what must x be for this to be true? X must equal?
To 1, because you must just cancel the 2's. Ne?
Yes, but if I cancel the 2's, x is equal to?
1.
No,
Ne?
look at the exponents. X is equal to?
Is it a 2 or 1?
2.
Oh, okay, then it's 2. But,
Yes, okay, yes. Sorry,
but
it's my handwriting. It's my handwriting. Sorry. Okay, so if I say to you that I've got negative 2 to the power of x is equal to negative 2, what is the automatic exponent of negative 2 here?
it's a 1.
1.
Okay, I get
Cancel
it.
the x's. X is equal to?
1.
That's where we got that from.
Thank you, ma'am.
All right. All right, okay. Sihle was asking the exact same question. So, ma'am, how did you get 1? That's how we got 1. Sihle, I hope that helped. I hope that helped. Okay. All right. Excuse me. Okay, I want us to try one of these examples. Okay. I want us to try these 2 examples, guys. These 2. I want you to sketch the graph of y is equal to 2x plus 1 and y is equal to 2 to the power of x minus, oh no, we just did that. Did we not just do that? No, we didn't. Okay, but I want you guys to sketch these 2 graphs, please. Remember the things that we need. We need an asymptote. And we also need a y-intercept. Now, that is for our positive graph. For our negative graph, we're also going to need an asymptote, but instead of just the y-intercept, we're also going to get an x-intercept. Okay, I'm going to give you guys 4 minutes to sketch both of these graphs. They're not difficult at all. Okay, and when you're done, pop your favorite emoji in the chat. Okay, 4 minutes, guys, go for it. Oh, no worries. Hello, Chloe. That's okay, my sweetie. It happens sometimes. That's all right. Unfortunately, you've missed quite a lot because we're about to finish this section, Chloe. It's a lot. Sorry, my sweetie. You can rewatch the first half of the video, okay? Once it's up on our website. Ah, Namane and Namisile are already done. So is Funzo. Sorry. Teacher knows. Mirula always with the weird emojis. I mean, sir. Sir. Excellent. I gave you guys 4 minutes. You finished in 2 minutes. So I'm going to assume that you guys are just like excellent at this stuff because wow. I know, Jasmine, like, typical Mirula. Yes, in this case, Atlechang, yes, they are both the same asymptote. They are. Okay. Oh no. Look at ma'am doing the most. Oh no. Fine. Yes, Namisile. Then you draw it
Hey.
at 0. Courtney, you draw it at 0. Hi, Namisile.
Hey, how are you?
I'm good, thank you. How are you?
I'm tired, but it's okay.
We move, my sweetie. We have to move.
Ish, we move. Okay. Can I try this and see?
Yes, absolutely. Absolutely. I'm loving that you put your hand up. All right. I'm just going to I'm going to write down the values over here so we know what's happening. All right. Okay. Is that other one +1? No, it's 2 to the power of x minus 1. All right. I just want to change these so we know which two functions we're working with. All right. Okay. All right, my sweetie. Do we want to start with 2 to the power of x plus 1?
Yes. Okay, so I said the asymptote, the y asymptote is equals to +1.
Good.
And then I said for the y-intercept, x is equals to 0, which is 2 to the power of 0 plus 1, which is equals to 2.
Excellent. All right. So I'm going to go draw in our asymptote. Yes. At 1. Good. There we go. All right. And we said that it crosses the graph at 2. So
Two.
okay. Is it a positive or a negative graph?
It's a positive graph.
Good. So it's increasing. You agree?
Yes, yes.
Beautiful. Okay. So increase is going in that direction. All right. What about this other one though?
And then for the other one, I said, I'm not sure. I said the y asymptote is equals to -1. I'm not sure if I'm correct.
Absolutely. True.
Oh, okay.
100%.
And then I said for the y-intercept, x is equals to 0.
Mhm.
And then I said 2 to the power 2 to the power of 0 minus 1, which is equals to 1 minus 1 is equals to 0.
Good. 0. Cool. All right.
And then I solved for the x-intercept. You said we should solve for it.
Well, in this case, if you solve for the x-intercept, your answer is just going to be 2 to the power of 0, or x is equal to 0. Yes? Did that happen?
Yes, that's what happened. I wanted to ask if that's correct.
It is correct, because you're going to get 0 is equal to 2 to the power of x, and then minus 1. If we move the minus 1 over, what do I get?
You say +1 is equals to 2 to the power of 0, and then I checked for an answer that will give me 1, which was 2 to the power of 0 and 1 to the power of 0, which is 1 and 1.
So 2 to the power of 0 is equal to 2 to the power of x. Therefore, x must equal to 0.
0. Yes.
So the point that my graph will go through is the point 0, 0. Okay. But what kind of graph is it?
Yeah, isn't it positive?
It is a
Positive.
positive.
Oh,
Right.
it's a positive.
My
Oh.
asymptote is over here, right? And my graph just
Yes.
needs that point like that.
Oh, the asymptote is the one that's in the negative section,
Yes.
but
The
the
graph is not
graph is
negative.
positive.
Yes.
Oh,
The graph is
okay.
not negative. The asymptote is negative. Okay.
Yes, okay, thank you.
You're very welcome, Masui. I see you did that excellently. You were just a bit confused as to where it went, but well done. Excellent
Thank you.
stuff. Very well done, my sweetie. Patu says, ma'am, what would the range be? What would the domain and range be? Okay, we're going to talk about the domain and range in next week's lesson, but we're going to speak about it. We can speak about it now. Now, remember, guys, our domain is always our x values, and our x values are defined everywhere. X is an element of all real numbers. Our range in the let's talk about this positive graph over here, the one of y 2 to the power of x plus 1. We know that our y is going to be an element of real numbers, but where can y not go? Y has to be what? Greater than which number? My y cannot go further down than a particular number. What is that number, guys? Look at this graph over here. The asymptote tells all. No, not 0. What is my asymptote? Good. My asymptote is 1. You will notice that the graph, let me remove this orange one. The graph, the purple graph, will get as close as it can to 1, but it will not cross 1. And we don't include 1 because 1 is an asymptote. So y needs to be greater than 1. That's it, Oami. Well done. Y is greater than 1. Okay. That is the domain and range. I hope that helps, part 2. Okay, y is greater than 1. Guys, do not, under any circumstances, do not say greater than or equal to. It's not equal to. The graph will never be equal to the asymptote. It's always just greater. All right. Okay, excellent. Give me a thumbs up if this section is okay for you, because we're going to move on in the next 30 seconds. All right, Asbonge, what's up? Can you unmute for me, my sweetie? You're still muted. Okay, swipe left or right and look for the big speak button. Hello.
Hey, ma'am.
Hi, my sweetie, what's up?
Can you please explain for me for the range?
Okay, so, okay, I can explain the range. Okay, that lag is everything. Yo, Jesus. Okay, so remember the range is going to be real numbers. It's made up of real numbers, my sweetie, but look at where my graph is. My graph is going up, so it needs to be greater than. But I know that my graph will never touch this point. Okay, so my graph will never be here at the point 1. My graph will only ever be above the point 1. It will only go up above the point 1. Even here, it will never touch the point 1. That is why we say that y needs to be greater than 1. Okay, Asbonge, tell me in the chat if that makes sense to you. Okay, the reason why we say that y needs to be greater than 1, because my graph cannot touch the point 1. All right, Abiani?
Ma'am,
Yes.
what happened to when we are like when we are hey, never mind. I got it. Never mind. Sorry.
Okay, are you just saying never
I
mind
get it.
because have you understood what happened? Are you okay, or are we just saying never
I
mind?
understood. Oh, yes,
Okay.
I understood. Sorry.
Okay.
Understood.
No worries, my sweetie. Excellent. All right. Okay, we're going to park exponential graphs because that's as difficult as they're going to get, except when we start looking at interpreting graphs, which is next week, then we're going to be
I'm
taking
okay,
two graphs
ma'am.
and putting them together. Hello?
I'm okay, ma'am. I understood. I got it.
Oh, okay. Oh, excellent, my sweetie. No, no worries. No, I'm moving on. You don't have to stress, Aviane. I'm moving on. Okay. All right, I just need you to mute for me, please, my sweetie. All right. Okay, we're going to be moving on to trig functions, and we're going to be looking at the basics of trig functions. All right, give me a thumbs up in the chat if you've already done trig functions at school. If not, give me a thumbs down so that I know where I need to start. Okay, Courtney says no. Flo says not yet. Namisile says no. Okay. Mutla says no. Christina no. Guhle no. Ea says yes. Sihle no. Roman no. Reabetu no. Esona nam. Okay, so there's a lot of no's. Okay, there's a lot of no's, but that's okay. Tiana's like, yes, but it was not make sure. That's fine. All right, so I will in just a second, Nico. I can do that at the end of the lesson. All right, I'll do that at the end of the lesson. All right, let's have a look quickly. Now, we have learned when we were doing the whole SOHCAHTOA. Do we remember SOHCAHTOA? SOHCAHTOA. We learned that if we have a Cartesian plane and we draw a line from the origin, going out like this and coming back down, we know that there's a particular angle that is made with the x-axis here. Let's say, for instance, this is a 30-degree angle here, right? Now, I know that if this is 30 degrees, and this over here is 1, and this over here is 2, and this over here is 1/3. I can use this in the same way that I could SOHCAHTOA, right? But what I want us to think of, guys, is I want us to think of the idea of this particular graph or this particular thing that we've just drawn here. I now need to bring it back. Okay. As a 3D idea. Okay. So what's actually happening is we have a 3-dimension. Yes, that's it, Tiana. We have 3 dimensions, right? So normally where we would draw that triangle ma'am just drew, we would be looking at the triangles inside a circle. That's why we call that line a radius. That's why that line that we draw like this is called a radius. That's why we call that side a radius. But now, I want you guys to not think of the circle itself. I want you guys to think of this as almost like a cylinder, okay? And whatever values I'm getting are actually being drawn here. So when we're looking at the circle, we're looking at the front face. But when we look at the graphs of sine, cos, and tan, we're looking at the side. We're looking at the side of our graph. Okay, so this is what has happened. If I go to my sine graph, guys, and I type in sine of 30 degrees, what is sine of 30 degrees going to give me? Sine of 30 degrees is how much? Good, Nico. Good, Ogushe. That's it, Asabuya and Patu. Good. It's a half, right? Now, if I had to go to this plane that we've just drawn over here, if I had to look at it on the side, sine of 30 degrees is a half. If I had to look at it like this, and I made this side 1, and I made this side 2, and this was 30 degrees, and I looked for sine, I would still have what is sine of 30 degrees over there? I'm going to get opposite over hypotenuse, which is still 1 over 2. It still gives me a half. Okay, so the graph that we see on the Cartesian plane and the graph that we see down here are exactly the same graph. It's just that one has been shifted from here, from the front face to the side face. That's the only difference. Okay, now if we continue down this vein, I'm going to lose someone. So I'm going to focus solely on this sine graph down here. Now, there are a couple of things we're going to note down. I want you guys to write this down as we go. Okay. The period, okay, the period means how long does it take me to go around my graph? How long does it take me to go from here and around and all the way back again? So the period of a sine graph is 360 degrees. The period of a cos graph is 360 degrees, but the period of a tan graph is 180 degrees. Okay, so when we talk about period, guys, we mean if I look at my sine graph and I go up and down and back to the beginning, that's 1. How long did it take me to go from 0, up, down, and back to the beginning? It was 360 degrees. So the period of my sine graph is 360 degrees. Okay, that's it. Like transverse waves. For those of you who do physics and you do AC and DC, this is a transverse wave. Yes, that's it. Yes. Okay, excellent. So when I do my cos, I can see that my cos starts up here at 1. It starts at 1. So if I have to start at 1, go down and come all the way back up to 1. How long does it take me to get from where I started again? From 1 all the way back to the 1 point again, it takes me 360 degrees. Okay. 360 degrees. The tan graph is a completely other different animal on its own. Okay. All it's saying is, how long does it take me to draw this wave? How long does it take me to start somewhere on this wave and draw a full wave? It takes me 180 degrees to draw a full wave. Okay, that's what the sine graph is saying. Not the sine, the tan graph. Yes. So basically, the amount of degrees it takes to make one full wave. All right. Now, the amplitude is how far up. How far up does my graph go? Okay. If you guys look at it, if we look from 0 to there, that's exactly 1 unit. And if we look from 0 to down here, that's exactly 1 unit. So if I start at 0 and I go to the top of my sine graph, that part over there, this part over here, this is my amplitude. Okay, so the amplitude of a sine graph is 1. Okay, the amplitude of a sine graph is 1. Same with a cos graph. Same with a cos graph. If we look at it from over here, from 0, how far up does it go? It goes to 1. And how far down does it go? 1. It goes 1 down. So the amplitude for a cos graph is also 1. All right, it's also 1. The amplitude of a cos graph is also 1. The tan graph doesn't have an amplitude. The amplitude of a tan graph is infinity. Because if you think about it, because the graph doesn't curve and come back down, it goes on forever in both directions. So the amplitude of a tan graph is not even a thing. infinity. It means it goes on forever, mnamane, in both directions, up and down forever. There is no amplitude. Okay, the tan graph, you can say that there's no amplitude because there's no point where it comes back. Like there's no maximum or minimum point. It just keeps going forever and ever in both directions. Okay, so there's no amplitude. All right, we're not going to talk about the vertical shift today. We're not going to talk about. Yes, Namisile, it is going to change. Yes, anyway, in the original graph. Okay, I was going to talk about that just now. Thank you, Teacher Nels, for putting that up for me. I was going to talk about that. Okay, when we talk about the asymptote, guys, the only guy who has an asymptote is tan. Tan has asymptotes at 90 degrees. Okay. Okay, so the asymptote is at tan is equal to 90 degrees. All right, down like this. Now, the three graphs that I've shown you over here, guys, we are going to call them mother graphs. Okay. These are the mother graphs. Mother graphs. Now, what this means is, if they ever do something different to our graph, then we need to see what has changed by comparing it to our mother graph. Okay, and that's where we're going to pick up on Wednesday. Okay, we're going to be comparing mother graphs. RAS.